Okay, we're gonna make making balanced compounds. So for potassium, the charge is +1, and then for chlorine, the charge is -1. So for this one, we are going to put potassium, which is K, and since it's a positive charge, you only need one potassium to cancel out the chlorine. So it looks like that. And then for aluminum and oxygen, since aluminum is +3 and oxygen is -2, you have to cancel them out. So you could do just switch the numbers like that. So it'd be A and then for potassium and sulfur, the charge is +1 and -2. So since potassium only has 1 and sulfur has 2, you have to have 2 potassiums and 1 sulfur.
Did you get that, kiddies at home? That's important because you're going to see it again tomorrow. Okay? Thank you. Now, as a review, we have to figure out, remember how to find the number of protons, electrons, and neutrons in an atom. We got this girl here off the street who just decided she was going to come in here and remind us how to do that. Okay, go ahead.
Okay, well, protons and electrons are like the same answer, and you take the atomic...
But where do you find it? On the period?
I'm saying that right now, okay?
Okay.
Mine.
Go ahead.
You get the atomic number, and for this case we're doing sodium, number 11, which is the atomic number, and that's how many protons and how many electrons there are. 11. Everyone get that so far?
Look, it's the same number all the time. Okay.
Okay. And then to find the neutron is a little tricky. What you gotta do is you have to get the atomic mass, which is the bottom number that has a whole bunch of decimals, and this one's like 22.98 is like the first two. So you look at this thing, and since the 9, you round it up to 23. So this is now 23. And now you take the atomic number, which is 11, and you subtract it. 3 minus 1 is 2. 2 minus 1 is 1.
She had to think about that one because her math is crooked. Look at the math. It's like a rainstorm. It's sideways.
That's how many neutrons there are.
Okay, people, remember, the neutrons is the subtracting one. Atomic mass rounded minus the atomic number. Okay, that's...
PE is the same. Yeah.
Look, I have her face in the circle thing here. Okay, that's all good. Now we're going to go back to the electron configurations, and that was pretty easy stuff. But as a review, we're trying to figure out how many electrons will fit in each of the s, p, and d orbitals. So go ahead.
Okay, the s orbital holds 2 electrons, and the p orbital holds 6, and the d holds 10.
So that was easy. Okay, hopefully none of you will miss that. Okay, because if you have to come to your house and cut your eyebrows off. Okay, because that's bad. Okay, lastly, here comes that little girl again, and she's going to do an example of how to do electron configurations, okay? Like the 1s, 2s stuff. Okay, all right, go ahead.
Okay, so it'd have 1, 2.
We need a 2s, because you're jumping right to a 2p. We need a 2s before you have a 2p.
Okay.
Like, I have 2p. And you have to have a 1s before you have 2p. Okay? So remember that.
So 2p would be like that.
She has to pee again before 2s. It goes 1s, 1, and then 2s. Okay, you have the 2s before you have to pee. Okay, remember that.
Wait.
There she has it. There she has the 2s before she has to pee. Okay, so now put 2p in there. All right, then that's perfect. You notice how the electrons spread out before they pair up right there? That's important because we don't want them to be uncomfortable having to share the same space, if you know what I mean. Thank you very much for joining us, and I'm Steve Scissors. Maybe we'll do this again, you know, if people watch it and stuff, okay? All right. Have good luck and stuff. Bye.